Bismillah, Assalamualaikum warahmatullahi wabarakatuh. So guys, welcome back to WTTS video. And today, I'm Alvin to be the MC in this video. And I got a friend, and he will become the speaker for this video. And we would like to talk about routing in Cisco. Okay, so Azmi, can you introduce yourself?
Okay, my name is Azmi Fauzan Akbar. You can just call me Azmi. Okay, let's just start the presentations. So here, first thing first, you gotta have your Cisco Packet Tracer app installed in your device. And especially when you're in Windows, you can just go up to the cisco.com or the website, the official website, and just grab the Cisco Packet Tracer simulations app or software. So once you get the Cisco packet tracer, well, I know you guys might have it. We're going to study about routing in Cisco. In Cisco. So first thing first, there are types of routing in Cisco. I mean, in networking, there are AGRP, as you know, EGRP, OSPF, RIP, and etc. And we are going to study two of this, AGRP and OSPF, at the same time. We're going to combine the topology into one single topology and try to make them communicate each other. So let's just write down the objectives. So the objectives of this video is going to be connecting routers or network using routing. And what kind of routines that we're going to use is depends on the situations, but we're here going to use AGRP and OSPF. And in the middle of the presentations, I'll show you how to connecting between two different routing protocols, that is AGRP and OSPF. So here, as you know, each of these routings has different way to communicate with each other, and how can you make them connect to how can you make them connect between those networks are using their distribute, as I might show you later on. So here it is. The first thing you gotta grab is a few routers. I'm going to use the 2egg11 iOS 15, and we're going to create some a lot of routers here. I'll say we're going to have 5 routers over here, and we're going to connect them using the automatic cable, and just press control, and you just gotta have uh, the connections on. So we have two sides, the right side and the left side, and we're gonna mark them with a box. So here, let's just start with bright blue here, fill color. Let's say this. So we're going to have this as the OSPF area, which we're going to have a little bit multi area here. The first thing first, but we gotta have the marked area first. So let's just continue and making the next one. I mean, we gotta change the color. So I'll say AGRP as dark green, dark lime, and this is going to be the AGRP area. Yeah, GRP area. So as you know, OSPF and eGRP has different systematic that you have to understand. In eGRP, you don't have to. You must use the same initial to connect to each other neighbors. Example, eGRP use an identifications called autonomous system or AS, and it is unobligated things to match them between the pairs. Like if you have router 2, 3, and 4, the identifications of routing must be the same, like it must match each other. As an example here, we're going to use a grp with the as number of 10. So here we have your grp as 10, and the next is going to be OSPF. So open source path first is going to be different with EAGRP. We are using a process ID as the identifications of their routing. But in this case, OSPF doesn't have the obligations for you to connect them, to synchronize them with the same exact process ID. You don't have to do that in this case. You just have to make sure that they are in the same, they're advertising the same interfaces, so there could be a neighbor. So the process ID could be randomized. It depends on what you want to be. It's like 1, 2, 3 is no problem, but I'll say 3. But that process ID 3, 1, 0, 1, 0, 1, and 2. So this is the ID of the OSPF. And now we're going to start configuring all of them. As you can see, all the routers here is on inactive interfaces. So they are in inactive interfaces. They are in the state of shutdown. So you can see that all the interfaces here are shut down or red. Now all you gotta do is try. We're going to head out into the configurations. So how's the IP addresses? But before we start, we're going to say this is going to be 10.10.0.30 network, and it's going to be 12.0.13 network, and it's going to be 23.0 network. So that's 30 because they only have two different, routers. And now we're going to start the configurations. We're going to head up into the configurations here. So come up to the CLI on the router 0. We'll say no here. And all you gotta do is configuring the IP addresses and head into the routing sections. So we're gonna enter the interface by don't forget to use enable. So you're gonna have the exact global mode, and then the configurations we're going to enter FA01 because it's the thing that is connected to the other routers here, and then we're going to no shutdown the interface. We're making sure that the interface state changed to up, and we're going to enter the IP addresses. So you're gonna need the IP addressing, and you're gonna need to make sure that their interfaces is up. So we're going to match the topology, the IP addressing in the topology. Let's say this is 10.10.0, but it's the network. So which one is going to be first and which one is going to be second? It depends on you. As long as it's in the same group of IP addresses, then it's all going to be okay, and you remember them. So I'll say this is 1, and the prefix is 30, so the subnet should be 252. Don't forget the address here. I kind of forget. Okay, now we've got the IP addresses set. Now what should we do? We're going to exit this and try to configure the routing. So how do you configure the routing? Is just write down router and OSPF, then write down the process ID number. So I'll say this is 0, but 0 is invalid, so you gotta use at least 1. And now we're going to advertise the IP addresses to connect to the peer. So let's just say network, and the IP addresses that we use to connect to the other neighbor, which is the router 1. So I'll say, in this case, you could have put the interface IP addresses or just the network. So what's the difference? If you do it like this, you gotta use wildcard as well. If you do it like this, you're advertising every IP addresses within the network, and don't forget the area. So I'll say area 0 or area 1, it depends. So you're advertising all the IP addresses within that subnet. But if you're doing something like this, network 10.10.10.1 and 0000 area 1, you're advertising the interface IP addresses. And this, what will this be? It's like you're going to advertise the IP addresses within these interfaces, and every IP addresses that have in that particular routers will be advertised through the network. So let's say I'm gonna advertise network 0.10.10.1.area 0 area 1, and I'm gonna make a loop back here. A loopback is usually used for routers or network devices to identify themselves, because sometimes you don't want to see complex number like random kind of numbers. You just want to identify which one is which one is what, like that. And you could use the router or SPF again, and use the command router ID here 111. You're going to set the router, the OSPF neighbor. Later on, you'll see it will assign as 111. But because I entered them after the network, I'll have to do the do clear IP OSPF process. Say yes. Because now we are done, we're going to exit the config router and do write. So we're gonna write the configurations or making sure everything is safe. So now we're going to continue to the router one. We're going to say no here, configuration, and F00 just no shutdown. Now we'll see that the interface state is changed to up, which means is now available to use, which you can use it now. And in default, every interfaces in Cisco routers are going to be shut down or disabled. So you're gonna enable it manually. And now we're going to apply the interface IP addresses. If we're going to match the same subnet, the same group IP addresses to the first router, the router 0. The router 0 has the 10.10.1, so we're going to use 2 because it is the group number here. We're going to use the loopback as well to identify the IP addresses. The 2. And now we're going to use the router SPF command, router ID, network 10.10.10.2.0.0.0.0 area 1, exit, and do right. Now we're going to configure area 1 first, but you gotta know that in SPF there is one specific area that you gotta need is the backbone area or the 0. So we're going to enter the router again, and now we're going to configure the next interfaces, which is the first fast antenna 01, no shutdown, and configure the IP addresses with 12.1, 255, 255, 252. Let's follow the path. And router or SPF 1 with network, we're going to advertise the IP addresses, but now we're going to try to use the 0 method. You write to save your configurations within the running configurations of the router. So we're going to continue to the middle router, or in OSPF we call the autonomous system border router. So it's connecting between OSPF network with other different routings protocol. So here we'll try interface F00, no shutdown. We can see that it's now up, so we're going to add IP addresses here. Exit interface loopback IP add. Let's say 222. So the IP addressing scheme in these simulations, you don't have to follow me literally. You don't have to follow me all through everything, but you just gotta use your creativity. As long as it makes sense in the, networking stuff. We're gonna make sure everything works. Now we see that we're going to advertise them, and we've got the connections able. So let me say, before we've been making the process ID into 1 and 2, and the difference is they only have the recognition. The only main point is when you're trying to when you're trying to see the configurations, you'll just see the identification was SPF2. Like, what's the point of SPF2? You gotta write it down or whatever. But in AGRP, you're not allowed to do this because the autonomous system number are not able to be different. You're going to have the same exact number. So let's continue. Do show IP root OSPF. So this is a command to see if the OSPF is running. Now we can see not running. I mean, they have database of the OSPF, and do show IP OSPF neighbor to make sure that they have form a neighbor to the other routers. So we're going to continue to the other interface and router OSPF2. Oh, okay. Just remember, I forgot the things. Because there's the autonomous system border router, you're gonna have two different routing protocols or two different routing types. We're going to make the AGRP. So we've decided the AGRP is going to be 10. And now, how to advertise in OSPF and in AGRP is not that different, but it's the same thing. Like you gotta do the 23.23.23.0.003. You don't have to enter any specific area because they don't use that kind of concept. You just gotta enter the prefix, the wildcard, and the network, and use the no auto summary because we're going to explain the further informations. Now just write down, just do write because we're going to save the configuration because we're done in this router. So we're going to enter router 3. No and conf in f00 no shutdown IP at 22.23.22 5.5.5.2, and then in the f01 no shutdown IP at how much is it 3434.125.5.5.5.2, and we're gonna use the same exact as number because if you don't, then you'll probably get into some troubles. Now you can see the SPF have formed, and we're going to continue no auto system and do right. Now we're going to head into the last router, which is this router, and content 00 no shutdown IP at 34.34.2 router AGRP10 net 34.34.42 no auto. Now, if you see usual IP root, you just see the root of AGRP because you don't have the you don't have the redistribute. So redistribute uh, is the way to connect within these two different routing protocols, metric, and we're going to use the router or SPF2 distribute AGRP10 subnets. And once we do that, we're going to make sure that everything goes well. We try IP root. Now they have form this one. Exit root show root. Okay, once they do that, now we can see the external root. It means that it is from the other routing type, so it is going to be okay. You can see they have now formed an agency. So I think that's all from me. Thank you so much for listening. I'll give back the opportunity to the MC. The MC.
Okay, thank you for you for the material. I mean, like you explained to us what is time routing is, like RIP, ASPAF, HRP, and how we can make it in the real topology. And like in this video, we use this CISCO packet transfer for simulation. Okay, maybe that's all. Thank you for speaker Azmi Akbar. And okay, thank you for watching. Let's close this video. Please close this WTTS with Alhamdulillah and Fatul Majlis. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.